I'm doing masonry veneers and cavity walls. So masonry veneers are the exterior facing. In our case, it's brick, and it's applied to the structural backing, which can be steel or timbers or stuff like that. And it protects the other wall components that is in the cavity wall from moisture and anything else that would come in. The veneer provides decorations. We have masonry solid walls is what we used to do all the time, and they're different because they're a lot thicker, and they had to provide like arches or some kind of something over any openings because of the wall is just so heavy. So now you can make them straight across, and there is decorative. And they also don't have weep holes, which we'll talk about here in just a moment. And cavity walls are two components. It has a inner white. Is that how you say it? White.
Mm-hmm.
An inner and an exterior white. And so this backup wall, which would be the interior wall, is the inner white, and the veneer is the outer white. And so we'll talk about a bunch of these components here in just a moment. The structural design concept behind a veneer and cavity walls are that the interior and exterior white need to share the resisting lateral loads. So, which they need to be connected, which is hard to achieve in practice. It's just like we use all the other components that I'm going to talk about to connect them and make them together, work together. So the first thing is a shelf angle, which is the preferred method on any of the above any of the floors that are not on a foundation. So this right here is the shelf angle, which is normally like a steel angle, and they're fastened with different fasteners. And the cavity is the space that's in between the inner and the exterior white, which also would be like right here in this space. Ties and anchors connect the masonry, the veneer, and transfers the lateral load to the backup wall. So this right here is a tie. It ties the veneer to the the steel. Yeah, the structural. Whatever, like in this case, it is steel. It could be timbers or components. We also need movement joints, which in this would be there would be like a horizontal space on top of veneer. Like you can't see it, but like it would be like in between one of these spaces. Like if this was the roof, then it would be like right here. And that transfers the vertical load, so like gravity and your live loads. And then we also sometimes have vertical space to allow for the horizontal, which would be like the wind or the seismic forces. So then we also have weep holes and vents, which the weep holes are are basically holes that let air and moisture escape out of the interior. And in the MSJC code, the minimum diameter, like most of the time they're circular, the minimum diameter would be 3/16 of an inch, but many of them suggest that you do more than that because they can get blocked with mortar as you're putting it in, or insects, like as the building's being used. And the maximum spacing between the weep holes is 33 inches. So they have to, they can't be spaced any more than that along the wall. And the vents are similar to the weep holes, but they have a maximum spacing of 66 inches, which is twice as much as weep holes. And then flashing, which is right here, directs any of the water that gets inside the cavity to the outside, so it can escape and keep the inside of the cavity as dry as possible. And then the air barrier, which is just right here, it's this black thing, which there's a bunch of different material that you can use. It minimizes the air going through the interior so that all of the air is kept from the inner white to the outside. And the compartment divider is just, it equals the air pressure from the inside of the wall to the exterior. Some design considerations is, like, you need to keep into account differential moment, which the lack of the horizontal moment, which you can use the movement joints to overcome that. You can also adjust the ties, which some of the ties, like, if the bigger the tie, the less flexible it is. So if you make them a smaller size and it makes them more flexible, then you can accommodate for the differential movement. And for also, don't make the backup walls more than 30 feet tall, like over the foundation. And then the exception to that is at a gable, it's 38 instead of 30.
Remind me to comment on that.
Okay. And then I didn't really want to go much into rain penetration because Hannah's going to talk about that on Monday next week, I believe. But some design considerations is that if excessive water gets inside of your wall, then the ties will corrode much faster. And in cold climates, you'll have the freeze-thaw deterioration of the veneer, which, like, since it's different pieces, like they expand and contrast, which will create cracks in the veneer. There's many different things that you need to make sure is in good quality, which is the stuff that you already have to have. You just have to make sure that it's enough, which the air spacing and make sure that it's airtight. The backup wall is not the exterior one, and make sure that everything is all of your materials, making sure that they're, good quality. And so, here are my references. Any questions?
How many of the bolts has to be kept to the wall? Means those 160 inch bolts.
Weep holes?
Yeah, yes, weep bolts, yeah. How many bolts and how regular they have to be kept?
Like,
Isn't it 36
How
inches?
often they have to be placed and what's the height generally?
I don't know what the height is, but they need to be placed, like, I believe, like horizontally, and they can't be get more than the lead poles could be 33 inches and 66 feet. But
The answer is they're placed there at the bottom.
My report goes
where
into
the
it.
flashing, and she'll talk more about it, where the flashing brings the water out, that's where the weep holes are.
But how can they keep the hole actually? Means
Uh,
after construction or before?
Yeah.
I talk about
She'll
that.
talk about that. And there are the way they used to do them. The easiest way to do is they use rope. And you'll see old buildings. They'll have rope, a piece of rope, and the rope is a wick. So the rope wicks the water out. That kept the mortar from getting in there. Then for a long time they've said, okay, no, we'll just try to keep the mortar out. And you'll see some where they just leave the mortar joint. Actually, they'll leave the whole joint out vertically. They now have some plastic inserts, and you're probably going to show us some of those, that they use, and they put that in the head joint, that plastic insert, and it'll be about this tall. It'll be taller than the joint. It actually slips between the bricks, and it's porous, so it lets the moisture in the air out. So there's been a lot of advances in what they use. So.
Gable, 38, whatever you wanted us.
Well, yeah, I was going to ask the class. I mean, she mentioned the vertical movement joint. And yes, it would be at the top. If you'd have shown brick underneath that, it would have been on the top of the brick. So on the top of the brick, underneath the shelf angle, you don't want it to sit, you don't want it to be tight. Okay? Why don't you want that veneer to be tight, top and bottom?
So that's for him to expand?
That's right. It has to expand and contract. Okay? Have you ever heard of Wilhelm? We've all heard of Kurt Drummond.
Yeah.
Well, Wilhelm was his ugly brother that used to sit behind it. And I don't remember whether it was Wilhelm or Kurt Drummond, but one of them, and was when I was in school actually, the entire bottom 2 stories, not the bottom 2 stories, because the bottom story is raised, right? And then the brick starts up above your head. The entire bottom 2 stories fell right off the wall. Luckily, it was in the summer. Nobody was here. Of course, a few years later, they started replacing and repairing all of them on Wilhelm.
You're saying all the brick fell off?
All of it fell off for 2 stories. The reason was they remodeled it and they closed that vertical control joint at the 3rd floor. Okay? And what it did is it literally failed the angle. Pushing up an expansion, the angle failed and both stories of brick fell off the building.
Damn.
So, I mean, that's because of that movement joint. So that is very important. Anyway.